Okay, day 11 of Advent of Code 2025, and this one's a bit easier. It's a graph problem, and the input looks like this here. So we've got nodes and their children, basically. So for like on line 1 here, we have ITG, that represents a node, and then that's connected to the node WVF and RVK, and this node is connected to this node, so it's a directed graph, actually, right? And I've actually, so these lines read in the input data, and then I actually plotted it here just to kind of get a sense for what the data looks like. It's not the best plot, and it's kind of hard to see, but we've got the out node here, we've got the SVR node here, and you can see the gray arrows not very well, but they indicate the direction of the edges between the nodes. And so there's clearly some structure here. And for part 1, they want us to calculate the number of unique paths from U to out. So I think U is this one over here. It's behind some other nodes, but it's the red star in this bunch of nodes. And so there are many ways to get from here to there, right? So they want us to calculate just the number of ways to do that. So let's write some code. We can do this recursively. So let me create a function, numPaths, that takes in a start node as a string and an end node as a string, and outputs the integer number of paths, right? So again, the nodes are represented by these 3-letter strings, right? So that's the input here. So our base case is if the start node is equal to the end node, then we return 1, right? There's one way to get from a node to itself. And otherwise, we will return so we're going to look at all the children of the start node. So we do have this graph variable that I defined up here, so we can use that to get the children of the node. So graph of start node will give us all the children. So we're going to do numPaths of n for n in that, and we're going to sum that up. And let's see, yeah, so it's n to end node. And yeah, that should be it for this. So we're going to call numPaths on U to out. And yeah, that's the answer for part 1. One thing we could do to speed things up is cache the results, basically. So Python makes it easy to do that with functools. So I can do @functools.cache, and this is basically dynamic programming, right? So the function may be called with the same start node and end node multiple times, right, as it considers all the different paths. So we don't want to have to recompute everything every time, so that's why we use this cache, right? But even without this, it seems to run fast because it's not a lot of data here. There are not that many nodes. So that's it for part 1. For part 2, they want us to find the number of paths between SVR and out. So I think SVR is called server in the problem description, but anyway, it's the SVR node, and we have to go from SVR to out, but DAC and FFT have to be on the path, right? So it could be in either order. It could be DAC and then FFT, or the other way around. But that's what they want for part 2. So if we just consider how many paths between SVR and out without worrying about the inner nodes, then, well, we can use our function that we just created. So it's SVR to out, and this could take forever because I don't have the cache on here. So let me put this back, and then yeah, then it's instant, right? If I if I run it like that. So that's a huge number. It's going to be, the answer to part 2 is going to be smaller than this because it's going to be a subset of paths that have DAC and FFT in them, right? So this is the easy way to do it. You just multiply the number of paths between, well, you look at the paths between SVR and DAC, and then multiply that with the paths between DAC and FFT, and then multiply that with the paths between FFT and out, right? And so, and then you add it to the product where FFT and DAC are reversed. So, I mean, one of these is going to be 0, right? Because depending on the graph here, you're not going to be able to go in both directions. So one of these is going to be 0, and the other one is going to be the answer, basically. So that's a nice one-line answer here. And so there's one thing we need to change because up here, the out node doesn't have any children. So I'm going to do, I'm going to give it a default value, right, of the empty list, right? So I'm going to rerun that and then run this guy, and that I think is less than this. Let's double check. It should be. It's not a lot less, or I don't know. It could be 100 times less or whatever. It is less. Let's divide it to see. Okay. Oh, it's less than 1%. Yeah, so that's the answer for part 2. Full disclosure, my initial solution for part 2 was a bit more complicated. It worked fine, but this is the solution I found when I looked at what other people did after I completed the problem. So, so yeah, there are definitely good resources online to help you understand these advent of code problems, and I would try to solve them on your own first if you can, and then it's good to see how others solve the problem. So. So that's what I did for part 2, and this is definitely the easier approach, especially if you've already got the numpaths function, right? So, so that's it for part 2. I hope that was clear. Let me know if you have any questions or comments. Thanks for watching, and I'll see you in the next video.